Alright, welcome to MECH2320 motor control. Alright, we're going to be doing a lot of hands-on this semester with a lot of the labs, wiring up a bunch of different types of motors that we have, working with VFD drives and things along those lines. So we're going to step right into chapter 1 here. It's a very generalized chapter. There's a lot of things in chapter 1 that we're going to step into in later chapters and get more in depth and more specific on a lot of things. But this is kind of just a general preview of talking about some basic motor control. So when we're done with this, you should understand kind of basic motor control and what we're doing. Some of you guys know that sort of stuff anyways. You got remote control cars or, different Arduino stuff that we've done in class, being able to make, different types of, servos go or DC motors go or those sort of things. So just make sure that we understand the difference between manual and automated control, okay? And different things we got to consider when we install them, and basic functions of a control system. And the one thing we're going to talk about a little bit is surge protection. All right, we did that a little bit in the electrical class, but we're going to move forward through a little bit more here. So when we talk about installation of motors and control equipment, there's really a lot that goes into it. You'll see some of the cabinets that we have around the classroom that you're going to be wiring up and doing those sort of things. But main things that we need to consider: power sources. All right, there's multiple different ways we can power motors and different types of electrical current that we can use or voltage that we can use. We've talked about those in the electrical classes, right? Whether we're talking three-phase or single-phase, or 208 or 277, or those type of different voltages and things that we've talked about. So the different type of motor connections. So when we look at a motor, we saw this in the mechanical class as well. All right, we look for its horsepower. Okay, if we're in Europe, we're talking about its kW, its kilowatts. Okay, we have its service factor, its temperature, rise, voltage, full load current rate, and its NEMA Code letter. We've gone through all that in the mechanical class, so looking at the nameplate on the motor gives us a lot of different information about the motor that we need to know regarding like hooking it up and how we can use it. All right, so if we look back at an old machine, this is one of the very first ones, or not very first ones, but this is an older machine here that has its self-contained motors and controls. Traditionally, when the line of production came out, they had one motor that turned a big rod above, and different machines were hooked up to that same rod, and that same motor worked on a bunch of different machines. There's a slide in the book, or a picture in the book, that you can take a look at it as well. But a lot of machines, they have their own integrated controls and motors now, or we run it all out of a separate building, okay, where there's a motor control center, where all the starters and all the buttons and all the controls are in one room, and everything is just wired out to the machines as well. So there's a couple different ways that kind of happens in real life, and we'll go over each one as we kind of get more in depth into the chapters here. All right, so we can look at the different kind of controller types, whether we have a start, a stop, a soft start, a variable speed, and those different kinds of control types and how we want to control the motor. Maybe we want the motor to ramp up slowly in speed and then go at a constant speed, or maybe we need instant torque, right? We're on a conveyor belt, we really got to get that going. So just different things like that. We always have to look at the type of environment the motor is sitting in, all right? It's a lot different if we're, sitting down in Bridgestone making tires versus we're in a textile factory where there's a lot of dust in the air and any kind of spark could ignite something. Or, we're out at a natural gas plant or things like that where we can really ignite. So we need different kinds of explosion-proof containers and those sort of things. And who helps us with that? All right, there's a bunch of code and standards that help. All right, we have OSHA. That's mainly for your occupational safety. Underwriter laboratory. Those are checking the fire code on, or not the fire code, but the fireproofing of different types of motors and electrical equipment. Because electricity can start fires. So it's got to meet whatever underwriter laboratories have. The NEC, that's the National Electric Code. Okay, so that's where it's a big old thick book. So there's different codes, whether we're building something in a factory or it's a factory design, or whether it goes down to your house. Okay, your house has to be up to code. You have to use a certain size wiring. Only a certain number of circuits can be on like a 20 amp or a 15 amp breaker. And it has to have that specific wiring. So in your house you have like a 14 conductor 2. All right, you can't run like an 18 gauge for your power, things like that, because it'll cause fires. All right, NEMA, those are in IEC, okay, those help with enclosures and those sort of things. So on the different motors and aspects like that. So we'll get through, and talk about those, like I said, more in depth. All right, so there's different types of control systems we can do on this. So manual control system, that means you, the operator, you do all the controls. You turn the machine on, you turn the machine off. You have a lever, so if you're stamping something, you press it down and you stamp it and you raise it back up. Kind of like the manual hydraulic press that we have in class and those sort of things. You are in control, and it is you doing all the manual controls, so stamping or things like that. Okay, if we have something that's semi-automatic, okay, we use push buttons, limit switches. This is going to be, kind of like if we took parts of our 870 trainer back there and broke them into smaller parts, okay? So that one's kind of semi-automatic because we still have to hit the start button for the process to go through. It doesn't fire up on its own with outside controls, but it can be automated through based on the handshake that the PLCs have back and forth when they talk. All right, it's semi-automatic. You guys, we've done a lot of stuff with push switches in multiple classes, just to understand, how we can use, a mechanical switch as an electrical signal and those sort of things. And we use them as maybe a pilot device, okay? A pilot device is a remote device that helps turn something on. So you're not physically at the motor turning it on. You can use a pilot device that helps control when to start. So like when we've talked about the scenario of like a tank motor starting, right? We have to be at a certain pressure and a certain temperature before we turn the motor on, to start mixing something, or, just a general example kind of like that. So those pilot devices are the pressure switch and the temperature switch. All right, based on those settings, the motor's not going to operate until then. Okay, now there might be a manual override that you can go over and manually mix it as well. So, just different scenarios we've talked about in PLC class and programming and those sort of things. All right, so we talked about, different types of enclosures and things like that, or starters. So, if we take a look at these two things, we have different types of manual starters here. Well, the one on the left, all right, that's in the enclosure, right, that's explosion proof. All right, so that when you flip the switch in there, there's no arcing or sparking that can escape to ignite something. But it's still just a manual toggle switch, right? We can go from start to stop. We have a lot of these on the Fanics, right? You just flip the switch, we have start, stop, and that puts it into, being able to turn everything on. So manual motor starters, all right, we have push button, all right, on the upper right hand corner, all right, so you can walk over, start, stop, kind of like the conveyor we have in class. All right, then we have manual motor starters. Now those can also be wired to be automatic, so you guys are going to start wiring up a lot of these in class, these manual motor starters, the bottom right hand picture. And I'll show you, we've gone over it on station 2, right? We can wire it up so it's automatic using the PLC, or if we look at the picture here, there's a red and a black button. Those help us start and stop the motor manually. So the motor itself, even though we can control it with a PLC and automatically turn it on and off, we can use a manual motor starter and press the button to make it start and stop. All you're really doing when you're pressing the button is we're closing the contactors. Okay, and you're going to see that in later chapters when we talk about that. But it's going to be, a basic switch like this. All right, everything has a circuit breaker on it because we have to use breakers for protection. All right, so remember, we're going to use circuit breakers. So if there's too much inrush current, the breaker will trip. So worst case scenario, the breaker might blow or something like that, but we can reset the breaker and figure out what's wrong. So that's the good thing about circuit breakers, whereas fuses, right? We blow a fuse, we got to replace the fuse every single time it blows. Circuit breaker just trips to the off position, protecting the equipment from the inrush of current. We got to figure out, hey, did we wire something wrong or what's happening here? And then we can use the circuit breaker again to run the circuit. So we always wire through a circuit breaker. That's just like everything in your house. That's what that panel is in your house. It's full of circuit breakers, all right, that protect each circuit. And then each, this is kind of a crude example here, but we have a switch that's on the motor too. So you hit the switch or you hit a push button and the motor turns on or off. But we can translate that circuit, all right, that single phase motor up there, into a schematic diagram. So you should be able to generally look at, I want you to be able to compare what it looks sort of like in real life and how we draw that schematically. Now we've been doing schematics, for a long time and through all the classes in here, so we should have a good handle of, going from real life to schematic here. Okay, so the most common method that's used, okay, is across the line starting. That's where we connect the motor directly to the power. So that's the top diagram we got here. All right, that's a schematic diagram of it. Notice there's just a start and a stop button, okay, and then we have a motor coil that interlocks it and keeps it going. We learned about that in PLC class, so that we could keep things running automatically and you don't have to hit there and stand there and hold the stop button or the start button, right, so that it works. Okay, so that's across the line where we have two different transformers, right, or not two different transformers. We have power coming in, that's the motor. So we have three-phase power going into the motor, all right, and then we tap some of that three-phase power and we transform it, and then we get our control voltage. So the separate voltage is there, but we can use that across the line there to do that. Notice there's another fuse there to help protect the current. Okay, and we're going to get into depth of this in the overload relays and those sort of things, all the different parts and pieces here. Okay, but if we have the schematic relay versus a wiring diagram, can you kind of see what the difference is between the two? Because wiring something up is a little bit different than just looking at the schematic. Notice this is the same thing, right? The top picture and the bottom picture are doing the same thing. One is just the schematic, that's the layout to let you know what's going to the motor and how we're operating the motor. What's used in the field is both of these, but for the most part, the bottom one is what you're going to use when you're going to wire everything up. So the box that you see in the bottom right hand corner, that's kind of like the manual starter we saw a couple slides back, where I was talking about, you can manually open and close the contactors to make the motor move or start and stop. Okay, so this is a separate box here, but you can see the difference between what the schematic diagram is versus the wiring. The wiring shows the exact locations of the wires and where they connect to. Now, there's even another step up where all the numbers are on there, and when you go into a panel, all right, your wires ideally should be tagged, okay, and there's specific numbers that they go into. But you guys will be following wiring diagrams in class and going to be able to wire motors up and get them up and running and start. So like I said, we're going to get into this in more depth, so don't feel that you have to memorize these, but what I do want you to understand between the difference between the two here is what the schematic does versus what the wiring diagram does. The wiring diagram shows the exact connections to everything. Schematic shows the layout of how everything is going to function. Okay. So we have different types of control system, right? We're still into that though. So we just talked about manual, semi-automatic, and now we're talking about automatic control. Okay, it's very similar to automatic control, only the operator doesn't have to initiate any action. So I was saying, what's semi-automatic? Our 870 trainer in the back, right? We still have to go over and initiate the start sequence for it to go through, and then it will automatically complete everything, assuming it passes all the tests that it goes through before we make that valve. But for us, automated control, it's all run by PLCs, all right, and it will automatically continue to go. The operator doesn't have to do certain things. Everything is fully automated. Okay, so let's just talk about basic functions of a motor here. And like I said, this is an overview. We're going to get into the different motor types and all those different things here. So when we look at this, all right, we have basic functions here. We want them to be able to what? Start, stop, very important. We're going to get into what jogging and inching a motor is and how we're going to do that. There's going to be a couple labs that you guys are going to do where you are going to jog or inch the motor, okay? It's literally you're just making the motor move, forward or backward at a certain, speed. We have speed control. You guys did this in the mechanical class, right, where we had the variable speed motor, and you're able to adjust the current flow into the motor. All right, that's when you guys did the compound gear drive, and you built all that, all right, and you used the little gray motor. So we use that for variable speed control. We use different motors for speed control, for torque, okay. And then how do we protect the motor and our circuit protection? All right, we've already talked about using breakers or fuses or those sort of things. Okay, but we really want to, check for surge protection, because that can not only damage the motor, it can damage all the controllers in the system. And we always got, safety, so that's when we talked about Underwriter Laboratory, NEMA, the NEC Code, all those different factors that play into, keeping a safe work environment, because these are dangerous. All right, they're machines, they can kill you. So you got to be careful. So we really want to talk about, surge protection, because the surge protection, even though it's a 120 volt motor, it can surge up to 600 volts or something. All right, maybe there's something jamming the motor, all right, and it's trying to overcome that initial torque. Well, it's going to draw in a lot more current to try and do that. So we want to protect that, drawing in more current, right, increasing voltage. So we really got to be careful there. So we want to be able to control voltage spikes so our motors don't become generators as well, or give off, a lot of different discharge to our electronic components that are controlling, because they're much more sensitive and they operate at smaller voltages. So a couple different ways that we help do that. Okay, we have a resistor, which is just a variable resistor that gets to be placed across the 120 volt coil. Okay, so we can use that. That's going to limit the inrush current. Okay, so that will really help save. So you can see in the upper right hand corner what that looks like. There's a fuse connected to it as well, so that we can protect the resistor as well. All right, so the fuse, right, that's our interchangeable component that really helps with us saving damage, prevents us from damaging equipment, because it's a maybe a 30-cent part versus a $20 part, and those sort of things. Okay, but there's what the resistors look like, and we really haven't talked too much about these in the electrical class, but it's a metal oxide resistor. All right, so we use that strictly to eliminate voltage spikes. So when you look at motors and things like that and you see those on there, that's to eliminate any voltage spike that can damage the motor, okay, and where they're set to. So like in the example here, it limits it, so it will only let the voltage spike up to 140 volts, and then it's going to control it back down again. Okay. Other ways we've talked about in the electrical class, right? Diodes. All right, we put a diode across the motor. Very, very important. Remember, what does a diode do? It allows current to only flow in one direction. Okay, very, very important there, because when we talk about it, these motors can become generators. So if they're not slowed down properly, all right, or if we don't use a clutch, or we use gravity to slow it down, or things like that, all right, that motor can actually become a generator. So we don't want current to be going back the opposite direction, because it can ruin all the electronics and control systems. So you'll notice, and even if you look at station 2 and I think station 6 has them as well on the starters there. Anywhere where we have the motors on our 870 trainer, you'll be able to look and you'll see that there's a diode across each one. So that's how we control the direction of current. It can only go one way, it cannot go back through the system, and that is to protect the system. So guys, that's just a brief overview of what we're going to be doing here in the motor control class. So like I said, we're going to get into depth in each one of those different components that we talked about, and even more. We're going to cover different types of motors and really kind of sink into them. And you guys are going to be doing a lot of hands-on in this class. But that's it for chapter 1, guys. All right. As usual, email me with any questions, or speak up in class, ask me some questions. Else, I will see you guys in class. Take care.